Recording. 7.2 notes, special right triangles. So, the very first thing that I need to let you know is that you're learning two shortcuts. Let me shorten this up a little bit. These are your two shortcuts that you're going to learn. You're learning a 45, 45, 90 degree triangle, which is called that because it has a 45 degree angle, a 45 degree angle, and a 90 degree angle. And this one's called a 30, 60, 90 because it has a 30 degree angle, a 60 degree angle, and a 90 degree angle. Most of the problems will not give you both angles. Most of the problems will have one of these angles covered up, and you're just going to have to know if this is 45 and that's 90, the other one's 45 too. It's a 45, 45, 90. And maybe they'll give you the 30, or maybe they'll just give you the 60, and then you have to know it's a 30, 60, 90. Make sense? Now, these problems, these are shortcuts instead of using the Pythagorean theorem. You could use the Pythagorean theorem, but instead you could use this as a shortcut. Let me kind of show you how it works. If you know what one side is equal to, let's say that this side, let's say that this side is 7. Then that means if you know this shortcut, this other side, this side that's down here, is also 7. Why on earth is my pen not wanting to work? And that means that the hypotenuse would be 7 root 2. Do you see how it works? It's a pattern. It lets you know that if you know the length of this side, you know the length of this side, and you know the length of the other side. Let me erase. That's not erasing. And let's call this side 13. What I want you to do is I want you to tell your partner what is this other leg and what is the hypotenuse. Go ahead and discuss with your neighbor. If you said 13 and 13 root 2, please raise your hand so I can see how many got it right. That is most of my class. Good job. I'm going to erase this. And then what we're going to do is we're going to try the same thing, and I'm going to check for understanding on the 30, 60, 90 degree triangle. So this side, this time, I'm going to call this side 10. And what I want you to do is with your partner, I want you to figure out how long is the leg and how long is the, let's call this the altitude. Okay? With your partner, discuss how long is the leg, how long is the hypotenuse, or whatever that is. I heard lots of right answers. If you said that this was 5 and this was 5 root 3, please raise your hand so I can see how many got that correct. That is almost 90% of the class that raised their hand. Perfect. I think you understand. The hardest part of this is what happens when. What happens when you get a weird number on this side? What happens when this side is equal to 3? Then what does S have to be if this is on the S root 3 side? Well, it'd be simple. You set them equal to each other. You divide by, let's say, a root 3. And then you rationalize this by multiplying by root 3 over root 3. Getting a pair. Reducing. And knowing that S has to equal root 3. That confuse you? We're going to be doing more of those. Those are the harder ones. Okay, but that's something I'm going to show you a little bit. So let me erase this. Let's go out to this part, which is why does this work? This is not something I wanted you to write down, but I wanted you to see it because I think it's an excellent explanation. Let me shrink that down so it shows up on the screen. Do not write this. This is why it always works. If you have one side and it's x, and you have another side and it's x, you learned way back in the when that if you have two angles that are the same, you have two sides that are the same. This is an isosceles right triangle. The two sides that are the same are these two. And if I know that, the Pythagorean theorem says a squared plus b squared equals c squared. This squared plus this squared should equal that squared. X squared plus x squared is 2x squared. And let's say that's equal to y squared. If I want to know what y was, I would have to square root 2x squared. Well, that means it's the square root of 2 times the square root of x squared. And these would cancel out, and you would have x root 2. What that means is no matter what you have, s root 2 is the formula for an isosceles right triangle. It always works. And it doesn't really matter if you use, our textbook uses s root 2. Our example uses x root 2. My other textbook that I taught before this used a root 2. It doesn't matter which letter you use. The way that I remember this, I have two things that are the same. That's why it's s root 2. Over here on the 30, 60, 90 degree triangle, the way I remember this is that there are three angles that are different. That's why it's s root 3. Across from the 30 is the s. Across from the 90 is the 2s. And across from the 60 is the s root 3. Now, why does that work? Because it's half of an equilateral triangle. Let me show you what I mean. If I had an equilateral triangle and all three sides were the same, let's just say that this side was a length and this side was the same length and this side was the same length. Doesn't matter what the length is. It could be 10, it could be 100, doesn't matter. I'm going to call it 2s and 2s and 2s. It's just a length that's the same on all three. And I chose 2s because if I cut it directly in half, then I know how long the bottom's going to be. One s and another s, right? That would be 2s. And if I had an equilateral triangle, all three sides are the same. All three angles would have to be the same, and then you could split it right down the middle, right? Into two 30, 60, 90s. S, 2s, and if you do the Pythagorean theorem on s and 2s as the hypotenuse, you'll get that this altitude has to be s root 3. It always works. It's a shortcut using the Pythagorean theorem without actually having to use the Pythagorean theorem. Make sense? Okie dokie. So, what we're going to do, we're going to label each side by the angle it's across from. We're going to figure out what the value of s is, and then we're going to use s to figure out the other two sides. We'll do that every single problem. If you would like to put your notes off to the side and do these with me, I would recommend doing that. We're going to start with number 7. Number 7 says, find the value of each variable. If your answer is not an integer, express it in simplest radical form. First thing I do, they only give me 60 degrees. So I'm going to fill in what this angle is. Then I know it's a 30, 60, 90 for sure. And then what I'm going to recommend that you do, just like we have here for number 1, label each side by the angle it is across from. So look at your shortcut. What's across from the 30 is s. Across from the 30, this side that has the y is going to be our s value. You go up to your shortcut. What's across from the 90? I go 30, then I go across from the 90 is 2s. And the third one across from the 60 is s root 3. I started with number 7 because this is like one of the harder ones that I was trying to show you before. Now we need to figure out what s is using this value that's given. 20 is the same thing. Where did that come from? Is the same thing as s root 3. These are equal to each other. If I want to find out what s is, you need to get the s by itself. This means it's s times the square root of 3. To get it by itself, you do the opposite of times by the square root of 3. Well, the opposite of times by square root of 3 is? The square root of 3 divided by the square root of 3 goes into each other one time. You're left with 1s on this side. Now, normally, you would be done at this point, but this is unrationalized. You do have to rationalize. What does that mean? That means no square roots in the denominator. And so I want to say this comes from the 0.3 notes, but I'm not positive on that. I'm going to put a 0.3 question mark because I'm not sure. I'll have to look it up for you later. And how do I rationalize? I multiply by whatever square root's in the denominator over itself. Technically, we're multiplying by 1. When you multiply by root 3 over root 3, you get a pair of 3s. That becomes root 9. And you know what the square root of 9 is. It is 3. The top has a coefficient and it has a radicand. Those can't mix. One's outside, one's inside. So it's 20 root 3 equals s. Like I said, the hardest part of this is rationalizing. And then once we get that, now guess what? We know what y is equal to. Y is equal to what value? If you know what this value is, tell the person you're sitting next to. What is y equal to? I heard a lot of you say the correct answer. 20 root 3 over 3. Good. Now I need to double that, because if I go and try to find x, that is twice as big as what s is. So if I'm trying to do that, I'm going to do 2 times 20 root 3 over 3. Guess what? That's 2 multiplies the numerator only. Coefficient times the coefficient, it cannot go inside the radicand. If you know what that is, tell the person you're sitting next to what you think it is. I only heard maybe 1 or 2 of you say the wrong answer, but the correct answer is 40 root 3 over 3. The 2 only multiplies the coefficient. It doubles the 20 root 3. It's numerator times numerator. Any questions? One other thing I want to show you here, just in case. If you're doing this and you're having a little trouble rationalizing, our calculators, the ones that I've recommended to you, the ones that are on our back wall in our room, can rationalize for you. For example, if you put 20 over root 3, just like this on the calculator, and you press equals, what it does is it tells you rationalize is 20 root 3 over 3. And then if you want, you can even multiply this by 2, and it will double it for you and tell you your answer should be 40 root 3 over 3. That's why I like these calculators, because the Casio's 115 and the Casio 300, FX 300, both do radical form, and that's a nice advantage of them. Turn that off. Number 13. Example number 2. A square has a diagonal length of 13 meters. What is the length of the side of the square to the nearest centimeter? So I have a square drawn for you. Let's make it green. And let's take this and draw a green thing right there. A square has a diagonal length of 13 meters. What is the side length of the square to the nearest centimeter? They are trying, whoever wrote this is trying to trick you just a little bit. Why are they trying to trick you? What do they give you this measurement in? But what are they asking you to round to the nearest? So the units are a little bit different. I would recommend to you that you figure out 13 meters is equal to how many centimeters. I would recommend you figure that out first. If you're not sure, you can multiply by a conversion factor. How many centimeters are in a meter? Centa means what? So if you multiply by 100 centimeters per meter, meters would cancel and you'd be left with centimeters. And so I think, or I would hope, that you would know that this is 1300 cms, centimeters. What are they asking us for? What's the side length of the square? Now it doesn't say this, but do you know what shortcut you should be using? Because it's a square, two sides are the same, two angles are the same. So that must mean that this is on a certain side. If I'm going to use a shortcut, let's label each side S root 2. This is S. This is S. Across from the 90 is S root 2. So what does that mean? That means the 1300 is on the S root 2 side. 1300 is equal to S root 2. How do you get the S by itself? Divide by root 2. And then you have to make sure that you rationalize. Here we're going to multiply by what over what? Let's see if we remember. Tell your partner, what are you going to multiply by if you're doing it by hand? So the top becomes 1300 root 2 over, but these two coefficients reduce, which comes out to 650 root 2. That is not our final answer, because our final answer has to be to the nearest centimeter. And the nearest centimeter is 650 centimeters times root 2. You need to actually multiply that on your calculator. 650, I'll show you what it looks like, times the square root of 2. Switch it to a decimal if your calculator doesn't have it in decimal form. It's 919.23 to the nearest centimeter. Does it round up? So it's just 919. This is about 900. Oh, you can't see that. Is about 919 centimeters. So far, so good. Any questions? Tia?
Square root 2 over square root 2 isn't it equal to 1?
No, it's not. It's equal to square root of 4. And what's the square root of 4? 2. If you, let's just do that. Square root 2 times square root 2. If there's a pair, they kind of go away. That makes sense? Common misconception. Let's jump to number 20. This one was a little bit tricky because we have A, we have B, we got to figure those out, and they give us 30 and they give us 10 root 3, and they only give us one angle. So the first thing that I did is I said, well, guess what? From here to here is 30. That does not tell me how long B is. And then this diagonal, there's got to be something I'm going to do with it. And there's this 60, there's going to be something I'm going to do with it. But I couldn't quite figure it out until I drew a line. And my line went from here to there. That's what I would recommend that you do on yours. Draw that line. Make sure that it's perfectly perpendicular. Create that right angle. And then you'll know that if this side is A, this other side is A. And now you can use this triangle, and hopefully you can figure out what this little angle is right here. This angle I'm pointing at, do a little bit of math. What angle is it? How many degrees? And now you can use a shortcut. Across from the 30 is A. Oh, I'm sorry, S. Across from the 90 is 2S. Across from the 60 is S root 3. So I write that in my picture. S, 2S, S root 3. And the value that they give me is, this is 10 root 3, and that's on the same side as 2S. That's my equation. 10 root 3 equals 2S. If you want S by itself, you have to do something with that 2. The opposite of multiply by 2 is divide by 2. If you have coefficients outside of radicals and they reduce them. Does 2 go into the 10? So that lets you know what the distance of S is. S is 5 root 3. That's this distance right here. I'm going to just write it really small underneath. 5 root 3. Now this distance, A, is on the S root 3 side. Since A equals S root 3, and you know what S is, plug it in. 5 root 3 times root 3. Then you can figure out what A is. 5 root 3 times root 3. If this is inside a radical, and that can multiply something else inside the radical. If you have a pair of them, they can pop out. So square root of 9 is 3. 3 times 5. A has to be 15 units long. There's no other way else. It's 15. Okay. That's what A is. Now B is this distance. 30 is the full distance, and then we have 5 root 3. If I'm going to find B, I'm going to have to do something. If you know what B is going to be, tell the person you're sitting next to what you think it is. If you or your partner said 30 minus 5 root 3, please raise your hand so I can see how many got it right. About 60% of you. Not all of you. Okay. So, full distance is 30. We knew this small distance was 5 root 3. Can we put them together when I subtract the 5 root 3 from the 30? You can only put root 3's together with other root 3's. As a matter of fact, let's say you forgot that. That's something I taught you earlier. And because I do like to show you things on calculators, 30 minus 5 root 3 on the calculator, if you press that in, this calculator, since it knows radical form, will keep it in simplest radical form. Kind of nice. It knows, don't put it together. You could switch it to a decimal easily, but in radical form, that's what it is. How do you switch it to a decimal on this calculator? See this SD button I'm pointing out? This stands for like standard and then decimal. Standard, decimal, standard. And it's a toggle. You can toggle back and forth. Anything else? Last example. 22. Turn that light off again. (22) says, right triangle ABC has an area of 32 root 3 centimeters squared. The measure of angle A is 30. Measure of angle B is 90. What's the length of BC, ABAC? Express all answers in simple radical form. I thought this question was, this is a little bit harder. So let's give it a go. The measure of angle A is 30. So I drew a triangle for you, and we need to know the smallest angle is 30 degrees. That's my smallest angle. I'll call it angle A. I'll put an A next to it. Angle B is 90 degrees. So I'm just kind of building this triangle. And it doesn't tell me what C is, but it says it's a right triangle ABC, so this has to be C. And I'm pretty sure you know how many degrees angle C has to be. Angle C has to be how many degrees? Say it out loud.
60.
Good job. They do not give me any of the other sides. They don't tell me how long this is or that is or that is. What they do tell me is that they have the area. So what I'm going to do, or I'm going to expect you to do, is you should still be able to tell me across from the 30 is what letter with our shortcut. What letter should this be? Across from the 30 is S. Using the shortcut, across from the 90 is, I do this in order every single time. Across from the 30, then across from the 90, then I go to across from the 60. And the way I remember that is there are 3 different angles, so that one has to have the root 3. If there's 2 that are the same, root 2, because we're talking about a 45, 45, 90. This one's a 30, 60, 90. Now I have some generic S root 3, and 2S, and they give me this information. The area is 32 root 3 centimeters squared. So I have to know what the area of a triangle formula is. I think you learned this in 5th or 6th grade. The area of a triangle, what's the formula? I like it. Now let's start plugging some things in. The area of this triangle, how long is it? Or how many square centimeters is it? Perfect. Equals 1/2 the base of this triangle. We don't know how long it is. It's in terms of S root 3, but we can write that in there for our example. S root 3. the height of our triangle. Remember, the base and the height always have to be perpendicular. The height of this triangle is? Now, some of you will look at this and not know how to combine this, but let's just go ahead and multiply coefficient times numerator. 1 times s would be s squared root 3, and technically this is all over 2. I'm just simplifying that right-hand side. Now I want to get this s squared by itself, so I'm going to have to do something to get rid of this root 3 over 2. I'm going to need to get rid of it. The easy way to get rid of fractions when you're multiplying by it is to multiply by the reciprocal. The opposite of root 3 over 2. I'm going to do this in a different color just so you can see it better. Is to multiply by 2 over root 3 on both sides. I'll do this step in blue. Why do I do that? Because 2 goes into 2 one time, root 3 goes into root 3 one time, and you'll be left with the variable squared. You'll be left with s squared on this side. Equals root 3 goes into root 3. You're left with 2 times 32 centimeters squared is 64 centimeters squared. I almost have s. If I want s by itself, you square root both sides. S will equal, technically when you square root a variable squared, it's either equal to a positive or a negative. But because we're talking about distance is always positive. So the square root of 64 is 8. The square root of centimeters squared is centimeters. And that's the distance. Technically, like I said, it's positive or negative, but I don't care about the negative value because we're talking about distances. That's what S is, but that doesn't answer my question. My question asked for something else. It said, how long is BC? How long is AB? And how long is AC? I know what S is. Do you know how long BC is? How long is BC? 8 centimeters. How long is AB in simplest radical form? And then AC is how long?
16.
And there's our final answer. Hopefully that helps you in 7.2.